Hello, and welcome to this online lecture. This is a lecture for week 2 of Math 136 at Ivy Tech. My name is Patty Kokish, and I'm going to be walking you through the materials for this week. Since we have no one on the line, I'm going to go ahead and begin the presentation. We're going to start with section R8, which is a review section. This should be review for you, but we're just going to go through a couple of things that you may have forgotten since you took your last math class. We're going to go through nth roots and rational exponents. Some of this stuff will be useful when you're doing some of the chapter 1 material. So the principal nth root of a real number a with n greater than or equal to 2 and an integer, symbolized by the nth root of a, is defined as follows. That's a little confusing, the wording, but really what it means is if you have nth root of a equal to b, that means that a equals b to the n power. So for example, if you have the square root of 4 equals 2, that means that 4 equals 2 squared. A has to be greater than 0 and b has to be greater than 0 if n is even. A and b are any real numbers if n is odd. So let's go ahead and simplify some nth roots. This is probably the most useful thing that you'll take out of this part of the presentation because you do need to know how to simplify roots. So if you have the cube root of 8, you should have a key for this in your calculator for the cube root. And if you do this, this one is just 2 because if you think about it, 8 can be rewritten as 2 to the third power. So the exponent and the root cancel one another out and you're just left with 2. So really what that means is 2 times 2 times 2, or 2 to the third, is just equal to 8. For this next one, you have cube root of negative 64. Now remember, you can have negatives under your radical if you have an odd root. And if you think about it, negative 64 is the same thing as negative 4 to the third power, or just negative 4 times negative 4 times negative 4. So again, the exponent and the root cancel one another out, and you're just left with negative 4. Now, don't let the fractions scare you too much. You treat these pretty much the exact same way. Here we have the fourth root of 1 over 16. So what you need to think about is just the 16, because we know that the fourth root of 1 is just going to be 1. And if you think about it, 16 is just 2 times 2 times 2 times 2, or 2 to the fourth. So you can rewrite 1 over 16 as 1 over 2, or 1/2, to the fourth power. And again, the exponent and the root cancel one another out, and you're just left with 1/2 as your answer. You can check this by doing 1/2 to the fourth power, and then changing it back into a fraction, and you should get 1 over 16. For D, what you need to keep in mind is that negative 2 to the sixth power is going to be some positive number, okay? Now the root and the exponent do cancel one another out, but since you have an even exponent, you know that whenever you raise it to that exponent, it's going to be a positive number. So really we have the absolute value of negative 2, which is just 2. So in general, if n is greater than or equal to 2 and an integer, and a is a real number, we have the nth root of a to the n is equal to a if n is greater than or equal to 3 and odd. And we have the nth root of a to the n equals absolute value of a if n is greater than or equal to 2 and is even. So these are the rules that we just used, but this is the actual rule written out for you. Basically, what you need to keep in mind is that the exponent and the root basically cancel one another out. So here are some additional properties of radicals that might be of some use. So if you have the nth root of a times b, what you can do is you can just split that up into two separate roots, nth root of a times nth root of b. If you have a fraction, you can do the same thing, except with division. So nth root of a over b is equal to the nth root of a divided by the nth root of b. And then if you have the nth root of a to the m power, one thing that you can do is you can kind of break it apart. So you have nth root of a then raised to the m power. So let's take the square root of 32 and simplify that. So what you want to do is you want to look for a perfect square that lives inside of 32. So if you think about it, 16 is a perfect square, and 16 goes nicely into 32. So all we're going to do is we're going to rewrite 32 as 16 times 2. So all we have is square root of 16 times 2. And then we're going to use our rule that we know. We're going to break this apart. So we're going to break this into square root of 16 times square root of 2. And when we do that, we know that square root of 16 is 4, since 4 squared is 16. So what this simplifies to is just 4 root 2. You'll always want to make sure that you've simplified radicals before you put those answers into MyMathlet. So you would never want to put square root of 32 as an actual answer. You'd want to put 4 root 2 as your answer. Cube root of 16. Now cubes are a little more difficult to remember, but if you just write down a few of them, that should be enough to get you through. If you recall, the cube root of 8 is a nice number, okay, because 2 cubed is just 8. So what we're going to do is we're going to break 16 down into 8 times 2. And then we break apart our cube root just like we did with our square root. We have cube root of 8 times cube root of 2. Now if you recall, cube root of 8 is just 2, so that's where this 2 comes from, and then we're just left with 2 cube root of 2, because this part is left over. There's nothing we can do with this. So your answer there is 2 cube root of 2. This one looks a little messier. You do need to write this 3 next to your root so that you know you're taking a cube root, not a square root. Okay, let's say we have something like this. The cube root of negative 16x to the 4th. This one is particularly nasty looking, but what we want to do is we want to break it apart into things that we can figure out. So again, the 16, we've already dealt with that. We know we're going to want to split that into the 8 and the 2. So we're going to split it into a negative 8 and a positive 2. And then the x to the 4th, what we want to figure out is what is the largest power that we can take out of there. And since we have a cube root, it's going to be x cubed. So what we do is we break down our x to the 4th, so it's just x cubed times x. And then what we're going to do is we're just going to break this apart even further. So this negative 8x cubed, that's going to be a nice cube root, so we're going to put those things together. And then the 2x is left over, so we're just going to stick those together as well. And then really what we're going to do is we're going to break this apart. Okay, I don't really like this step that's shown here. I would prefer to go right to this one. So what you're going to do is you're going to break it apart so you have cube root of negative 8x cubed, which can also be written like this right here. And then you have cube root of 2x. Now, cube root of negative 8 is going to be negative 2, so that's where this negative 2 comes from. Cube root of x cubed, if you recall, the exponent and the root basically cancel one another out, so you're just left with x. And then you're still left over with a cube root of 2x, so that stays inside. All right, let's do one that doesn't look so nice again. So let's do the 4th root of 16x to the 5th over 81. So again, we want to look for perfect squares that fit inside of these. Now, this one is actually pretty nice because 16 can be rewritten as 2 to the 4th, and 81 can be rewritten as 3 to the 4th. Now we want to look for a nice power that lives inside of this x to the 5th. So we're looking for x to the 4th, okay, or some multiple of that. So what we can do is we can break down our x to the 5th so that it's x to the 4th times x. And then what we're going to do is we're going to group everything that's a perfect 4th root or 4th power together. So we have 2x over 3 all raised to the 4th. That comes from this 2 to the 4th, x to the 4th, and 3 to the 4th. And then we have this little x kind of left over. And then if you look here, what you can see is that we've broken it apart into 2 separate 4th roots. So we have the 4th root of 2x over 3 to the 4th times the 4th root of x. Now if you recall, this root and the exponent are going to cancel one another out, but we do need to put absolute values out here. Normally, if we just have numbers, we know whether they're positive or negative, and so we can just take the absolute value always, keep it positive. But in this case, we have an actual x in our answer, so we need to leave the absolute values around it in case x is a negative number. And then we're just left over with this fourth root of x. So our final answer for that one is the absolute value of 2x over 3 times the fourth root of x. All right, we can also combine like radicals. So let's say we have negative 8 times the square root of 12 plus the square root of 3. What we're going to do is we're going to break apart our 12 so that it looks basically like the other root. So 12 can be broken down into 4 and 3. So what we're going to be left with is negative 8 times negative 8 times the square root of 4 times 3. So basically what we're doing is we're looking for a perfect square that lives inside of 12. Hopefully it'll also combine with this one so that we can make it look a little nicer. And then we're going to break apart this 4 and the 3 so that they're in separate roots. So we have negative 8 times the square root of 4 times the square root of 3 plus the square root of 3. Now, square root of 4 is just 2. So negative 8 times 2 gives you negative 16. Negative 16 root 3 plus square root of 3. Now these are actually like terms now since they both have square roots of 3. So what you can do is you can combine them. This has a negative 16 out front. This one has an invisible 1. Okay, negative 16 plus 1 should give you negative 15, and you're left with still the square root of 3. So your final answer is negative 15 times the square root of 3. Okay, now if you want to rationalize your denominator, or what that really means is you want to get your denominator free of any radicals, what you're going to do is you're going to do some kind of fancy multiplication in order to make that happen. So here are some examples that you're going to follow. So if a denominator contains the factor square root of 3, then all you have to do is multiply by that exact same thing in order to get rid of it. Now, if your denominator contains kind of where you have two pieces, okay, you have a square root and then you have another number, what you need to do is you need to flip this sign on the second piece and multiply by that. So if you have square root of 3 plus 1, you multiply by square root of 3 minus 1 in order to get rid of it. If you have square root of 2 minus 3, you multiply by square root of 2 plus 3 in order to get rid of it. And then the same is true even when you have two square roots here. If you have square root of 5 minus square root of 3, you multiply by square root of 5 plus square root of 3. And then right here, if you have cube root of 4, what you need to do is you need to make it so that you have a nice cube root underneath. So you have to figure out 4 times what gives me a perfect cube. And 8 is a perfect cube, so we know that 4 times 2 should give you that perfect cube. So let's go ahead and rationalize the denominators of each of these. Now keep in mind that we never want to change anything, so we need to always be multiplying by some form of 1. So when we multiply by square root of 3, for example, in this first one, we're not just going to multiply our denominator by square root of 3, we have to multiply our numerator by that as well. So if we multiply by square root of 3 over square root of 3, what we're going to be left with is 1 times square root of 3, which is just square root of 3. And then in our denominator, we have square root of 3 times square root of 3. That can be written as square root of 3 squared. Now if you notice you have a square root and a square, those cancel one another out. So your answer is just square root of 3, that's your numerator, divided by 3. Now you know it's rationalized because you don't have any roots in the denominator, which is what we want. Now this one here, in order to get rid of this, all we need to do is multiply by square root of 2. So we have 5 times square root of 2 divided by 4 times square root of 2 times square root of 2. So our numerator, we can't do anything with that. That's just going to be 5 root 2. Now what you'll notice is you have square root of 2 times square root of 2, so we rewrite that as square root of 2 squared. And then again, this is going to be the same idea as the last one. The square root and the square cancel one another out, so you're just left with 4 times 2, which gives you an 8 in your denominator. So your final answer is 5 root 2 over 8. Now this last one, since you have square root of 3 minus square root of 2, what we're going to need to do is we're going to need to multiply by the conjugate, okay, which is going to be the same thing but with a plus sign. So we're going to multiply by square root of 3 plus, oh, this problem turned into a different one. I apologize for that. So we're going to be doing square root of 2 divided by square root of 3 minus 3 root 2. So pretend like there's a 3 out here. It was missing from the original problem. I apologize. So what we're going to multiply by is square root of 3 plus 3 root 2 over square root of 3 plus 3 root 2. Now this is not particularly nice looking, but what we're going to do on the top is we're going to distribute. So we have square root of 2 multiplied by the entire quantity, square root of 3 plus 3 root 2. And then in the denominator, what we're basically doing is FOIL, but all you need to keep in mind is that the outside term and the inside term, when you multiply them, are going to cancel with one another. So really what you're left with is you're left with the first term, which is going to be square root of 3 times square root of 3, or square root of 3 squared, and then the last two terms, which is minus, because you have a negative and a plus, and then you have 3 root 2 times 3 root 2, which is the same thing as 3 root 2 squared. So we're going to do a little bit more to this to make it look a little nicer. Square root of 2, we're going to distribute that. So what we have is square root of 2 times square root of 3. And then we have square root of 2 times 3 square root 2. So we're rewriting that as 3 square root of 2 squared. And then in the denominator here, the square root and the square, again, they cancel. So we're left with 3 here. And then what's going to happen here is the square root and the square are going to cancel. So you're left with 2 times 9, since 3 squared is 9, which gives you 18. So if we do a little more simplifying, square root of 2 times square root of 3, that's going to just be square root of 6. Square root of 2 squared is going to be 2. 3 times 2 gives you 6. So we have square root of 6 plus 6. And then 3 minus 18 is just negative 15. So that's where they get this denominator. And then all we've done is just rearrange this so it looks slightly nicer. There's nothing wrong with this answer here, the square root of 6 plus 6 over negative 15. But what they've done here is just they brought the negative out front and they rearranged the numerator so it looks a little nicer. So their final answer is negative 6 plus square root of 6 all over 15. Okay, if a is a real number and n is greater than or equal to 2 is an integer, then a to the 1 over n power is the same thing as the nth root of a. So what that means is that we can rewrite square root as an exponent, which is 1 over 2. So if you look at these problems here, we have 4 to the 1/2 power. That's just going to be the same thing as the square root of 4. So whatever is in the denominator here, that is your new root. And you just ignore the 1. So the square root of 4 is just 2. So this answer is just 2. The other thing I want to point out is that you can put this in your calculator to check it. If you do 4 and then you hit your exponent key and you do the 1/2 power, make sure that you put that in parentheses and then hit enter or equals. You should get 2 for that answer. Now if you have 8 to the 1/2 power, we're going to rewrite that as the square root of 8. Now hopefully you remember you can't just leave it as the square root of 8 because that's not simplified. Square root of 8 is really square root of 4 times square root of 2, which simplifies into 2 root 2. All right, negative 27 to the 1/3 power is the same thing as the cube root of negative 27. And negative 27 is a perfect cube. Your answer is just negative 3. 16 to the 1/3 power is just the cube root of 16, which again we can simplify into cube root of 8 times cube root of 2. Now cube root of 8 is just 2, so we're just left with 2 times cube root of 2. All right, now if we have a fraction and an exponent that doesn't have a 1, what you want to keep in mind is that a to the m over n power is the same thing as the nth root of a to the m, which is also the same thing as nth root of a, then raised to the m power. So again, this looks a little confusing, but let's look at a couple of examples. So let's say we have 4 to the 3/2 power. We're just going to rewrite that. This 3 stays as an exponent, but the 2 becomes our root since it's in our denominator. That's just using the rule that we used on the previous slide. So really what we have is we have the square root of 4 raised to the 3rd power. Now you all know that square root of 4 is just 2. So all we have here is just 2 cubed, which just gives us 8. This one here, negative 8 to the 4/3. The 3 becomes our root. So we have cube root of negative 8, and the 4 stays as an exponent. The cube root of a negative 8 is just negative 2. Negative 2 to the 4th power is just a positive 16. Down here we have 32 to the negative 2/5 power. So this 5 becomes our root, so we have fifth root of 32. The negative 2 stays as our exponent. Now the fifth root of 32 is just 2, since 2 to the fifth gives us 32. So we have 2 to the negative 2 power. Hopefully you remember exponents with negative signs. You can move them to the denominator as long as you change the sign. So this is the same as just 1 over 4. And 25 to the 6 over 4 power. One thing we can do is we can reduce 6 over 4 to 3 over 2. So this is just 25 to the 3/2 power. So we're going to rewrite this as the square root of 25. It's square root because we have a 2 in our denominator, raised to the 3rd power. The square root of 25 is just 5, so we just have 5 cubed, which just gives us 125. Okay, now let's simplify a couple of expressions that contain rational exponents. So let's say we have x to the 2/3 times y times x to the negative 2nd power times y to the 1/2 power. So what we're going to do is we're going to do some distributing with our 1/2. So we're going to take x to the negative 2nd power, raise it to the 1/2 power, and we're also going to take y, raise it to the 1/2 power. So that's all that was done there. And then we just make this look a little nicer. Let's see, we have x to the 2/3 power still. We have our y still from here. X to the negative 2 to the 1/2 power. If you recall, when you have an exponent raised to an exponent, all you have to do is multiply those two things. So you have negative 2 times 1/2, which just gives you negative 1. And then you still have this y to the 1/2. And then we're just going to group it so that we have our x's next to each other, we have our y's next to each other, so all we've done is just rearranged. And then all you need to do is just add these two things since we were multiplying. So negative 1 plus 2/3 just gives us negative 1/3. So we have x to the negative 1/3. This is y to the 1st power times y to the 1/2 power. 1 plus 1/2 gives us 3/2. So we're just left with x to the negative 1/3 times y to the 3/2 power, which we can rewrite with positive exponents. So what we want to do is we want to leave our y to the 3/2 in the numerator because it was already positive. And in order to make this x to the negative 1/3 positive, all we have to do is just move it to the denominator and make it positive. All right, if we move down to b, what we're going to do here is kind of something that's a little bit useful. We have the negative 3 power out front. We want that to be a positive power just so it's a little easier to deal with. So what we can do is we can flip our entire fraction upside down, which is what was done right here, and then make our exponent positive. So right now we have y to the 2/3 power divided by 2x to the 1/3 power, all cubed. And then we're just going to distribute this 3 to both and multiply. 2/3 times 3 just gives you 2, so we just have y squared. And then we have to distribute this to everything. 2 cubed, that's this part right here, x to the 1/3 times 3. So really you're left with y squared over 8, since 2 cubed is just 8. And x to the 1/3 times 3 is just going to be x. So you are left with y squared over 8x. All right, this down here, what we have here is we have 9x squared times y to the 1/3 divided by x to the 1/3 y, which is all raised to the 1/2 power. So what we would like to do is we'd like to go ahead and get all of our x's together, all of our y's together, and we want to keep them positive. So our x's, since the higher power is in the numerator, we're going to leave it up there. And since we're dividing, we subtract our exponents. So we have 9x to the 2 minus 1/3 power. Basically all you're doing is you're moving this x to the 1/3 up top. And then since our higher power for our y is in the denominator, we leave our y in the denominator. So we have y to the 1st, which is from here, minus 1/3. And then we go ahead and just combine these fractions. 2 minus 1/3 gives you 5/3. 1 minus 1/3 gives you 2/3. And then we have to go ahead and distribute our 1/2. Which is not so nice looking, but we're just left with 9 to the 1/2, which is going to be 3. 5/3 times 1/2 gives you 5/6, so we have 3 times x to the 5/6. And then we have 2/3 times 1/2, which gives you 1/3. So we have 3x to the 5/6 equals, or sorry, divided by y to the 1/3. That one is particularly nasty. All right, so that was some review from basically your review chapter of your textbook, which should be from a previous course. Some of those are probably a little more difficult than what you'll see, but I wanted to do some of the more difficult problems so you see what you can face. Now we're going to be doing section 1.4, which is a new section for you guys. We're going to cover radical equations, equations that are quadratic in form, and then factorable equations. So let's start with a radical equation. Let's say we want to find the real solutions of the equation cube root of 3x minus 1 minus 2 equals 0. So when you're solving something like this, what you want to do is you want to get the root by itself. Okay, so what we're going to do is we're just going to add 2 to both sides first. So you're left with cube root of 3x minus 1 equals 2. Now, in order to get rid of the cube root, all you have to do is cube both sides. So we cube the left-hand side, we cube the right-hand side. The cube root and the cube are just going to cancel one another out. So you're just left with 3x minus 1 equals 8. So you get 3x equals 9. Divide both sides by 3, and you get x equals 3. You want to make sure that you check it. Okay, so your solution set is 3. Oops, and it didn't check it here. But what you would want to do is you'd want to plug it back in, okay, and you want to make sure that it works. So 3 times 3 gives you 9. 9 minus 1 is 8. Cube root of 8 is 2. 2 minus 2 is 0, so that one works. All right, let's look at this one here. Let's say we have the square root of x plus 1 equals negative x plus 1. The square root is already by itself, which is good. Okay, so in order to get rid of it, we need to square both sides. Now, don't be tempted to just square the left-hand side. If you square the left-hand side, you also have to square the right-hand side. The square root and the square are just going to cancel each other out, so you're just left with x plus 1 on the left. And then I trust that you all know how to FOIL this. Negative x plus 1 squared is going to be x squared minus 2x plus 1. And then all we need to do is just move everything so it's all on the same side. What you could do is you could leave the x squared on the right-hand side, subtract x, and subtract 1. And what you're left with is 0 equals x squared minus 3x. You can solve this by factoring. There's a common factor of an x that you can take out. So you're left with x times x minus 3 equals 0. And if you split this, you're going to get x equals 0 or x minus 3 equals 0, which gives you the solutions x equals 0 or x equals 3. And we want to check those again, so we're going to plug in 0 first. Square root of 0 plus 1, that's just going to be square root of 1, which is just 1. Negative 0, that's just 0. 0 plus 1 is 1, so we get 1 equals 1. That one works. And then we want to check 3 as well. So if we plug 3 in, we have square root of 3 plus 1, that gives you square root of 4, which is 2. And then you have negative 3 plus 1 is negative 2. 2 is not the same thing as negative 2, so that one is extraneous. Okay, that one does not work. So your only solution is x equals 0. So you need to make sure when you do radical equations in my math lab that, especially when you get 2 answers, you need to check one of them, because a lot of the times one will be extraneous. But even when you get one solution, make sure that you check that as well. So the solution set is just 0. All right, let's do one more here. Let's say we have square root of 5x minus 1 minus square root of x equals 1. Now, in this case, we have square roots that are not by themselves, okay, and it's going to be impossible to get them by themselves. But before you square both sides, you do want to make sure that you only have one square root on each side. So what you want to do is go ahead and move this square root, the negative square root x, over to the other side, and then square both sides. So we have square root of 5x minus 1 squared equals square root of x plus 1 squared. So again, the square root and the square, just like last time, those are going to cancel, so you're just left with 5x minus 1. And again, I trust that you guys know how to factor, or sorry, not how to factor, how to FOIL. So you should be left with x plus 2 root x plus 1. Now this one, you'll notice we did all of this and we're still left with a square root. That means we're going to have to kind of use the same methodology to make it look nicer again. So we want to get our x's all on one side. The square root, we kind of want to get it by itself, okay? So we're going to move everything away from it. So we're going to subtract x from both sides, so we're left with 4x. We're going to subtract 1 from both sides, so we're left with negative 2. So we have 4x minus 2 equals 2 root x. In order to get rid of this, Well, I'd go ahead and divide by 2 first, since everything divides nicely. Dividing everything by 2 just leaves you with 2x minus 1 equals square root of x. And then square both sides. So you have 2x minus 1 squared equals square root of x squared. Again, you're going to FOIL this, so you're left with 4x squared minus 4x plus 1 equals x, since square root of x squared, the square root and the square cancel one another out. Move all of your x's and everything to one side, so you're left with a quadratic equation that you can solve. So you're left with 4x squared minus 5x plus 1 equals 0. This factors. If it doesn't factor, you could use quadratic formula, but this one's going to factor into 4x minus 1 times x minus 1. And if you solve that, you should get x equals 1/4 or x equals 1. You want to check them. The 1/4, it looks like, does not work when you check it. Okay, and I'll leave that to you guys to check. But if you plug 1 in, that one does work. Okay, so x equals 1 is the only solution that works. Okay, let's look at something like this. Let's solve an equation that's in quadratic form. So let's find the real solutions of this equation. We have x minus 2 squared minus 3 times x minus 2 plus 2 equals 0. Now, this one looks a little tricky, but what you want to notice is that you have these repeating x minus 2's. Okay, so you have an x minus 2 here and here. What we're going to do is we're going to treat this like a quadratic equation. We're going to use something called u substitution. So we're going to let u equal x minus 2. So all we're going to do is everywhere we see our x minus 2, we're going to put a u there. So I'm going to rewrite this. So really I have u squared, because it was x minus 2 squared, minus 3u plus 2 equals 0. Now if you look at this, this looks much nicer than the original. So we're going to deal with this equation here. It factors into u minus 2 times u minus 1. So we get solutions of u equals 2 or u equals 1. So these are our solutions, but they're in terms of u, and what we would actually want is we want our answer in terms of x. So what we know is that x minus 2 has to either be equal to 2 or x minus 2 has to be equal to 1, because those are my values for u. So all I need to do is solve that. So I get x equals 4 or x equals 3. That's just obtained by adding 2 to both sides. So my solutions are 3, 4. All right, let's do another one like this. Let's say we have x minus 5 times the square root of x plus 6 equals 0. Now this one you could use the methodology that we used before, getting everything away from the square root and then squaring both sides. That would definitely work. But if you'd like, what you can do is you can do u substitution again. So we're going to let u equal the part that we don't like, which is our square root of x here. It's also important to note that u squared would then just be x. So anywhere we see an x, that's going to be taken the place by u squared, and anywhere we see square root of x, that's going to be taken place by u. So what we're left with is x, which is u squared, minus 5 square root of x, which is minus 5u, plus 6 equals 0. We factor this, and we solve. We get u equals 3 or u equals 2, and then we just solve this equation. So we know that square root of x equals u, so we have square root of x equals 3 or square root of x equals 2. In order to solve that, you just square both sides. So we get x equals 9 or x equals 4. So that's our solution set, 4 and 9. Make sure you always go back and check to see that it works. All right, let's say we have something like this here. X cubed minus 2x equals x squared. Now this doesn't look very nice, but you'll notice something. If you move everything to one side, we're just left with x cubed minus x squared. We've written them in descending order. Minus 2x equals 0. Now this actually is not that bad, because if you look at this, they all have an x. So that means that you can factor an x out, and then you're just left with x times a quadratic, which is much nicer. So you have x times x squared minus x minus 2 equals 0. And this further factors into x minus 2 times x plus 1. So we're left with x times x minus 2 times x plus 1 equals 0. And our solutions are just going to be x equals 0, x equals positive 2, and x equals negative 1. So we have negative 1, 0, and 2 as our solutions. All right, let's say we have something like this here. x cubed minus 3x squared minus 4x plus 12. This one we can actually do factor by grouping. So we're going to look at this first group, and if you notice, you can take an x squared out of both of these. So we're going to factor an x squared out, so we're left with x squared times x minus 3. And then for these two, we can factor out a negative 4. So if we factor out a negative 4, we're left with negative 4 times x minus 3. Now if you notice here, x minus 3's exist in both places. That's how we want it to work when we have factor by grouping. And so this factors even further x squared minus 4 times the quantity x minus 3. Now x squared minus 4, hopefully you recognize that. That's the difference of two perfect squares. So that's going to factor into x plus 2 times x minus 2 times x minus 3, which is going to give us three solutions, negative 2, positive 2, and positive 3. So that's our solution set there. Again, I would always suggest that you check all of these, especially on a quiz where you only get one shot per question. Okay, section 1.5 is about solving inequalities. So interval notation can be a little bit tricky to begin with for students. So I want to spend a couple of minutes just going through it. I've written up a couple of rules here to always get the intervals correct. Number one rule is to always draw a number line. So a lot of times students don't really like to draw the number line, but I find it very, very useful. Then what you're going to do is you're going to read the number line from left to right, and you're going to write down the important numbers where the shading either starts or changes. Now, if the shading goes to the ends of the number line, then you're either going to need to use a negative infinity or a positive infinity symbol. And then number 3, if a number is included, then you use a bracket, else use a parenthesis. So for example, for this one, if you have a comma b, that's the same thing as this inequality here, x between a and b. So if you look on your number line, if you were given this inequality, a is less than x is less than b, you guys would all know how to draw it on a number line. All right, and then in order to write it in interval notation, what we do is we look on the left-hand side, we're looking for shading. We have shading right here, so we're going to write down a, and then our shading goes and it stops at b. And then we use parentheses because those numbers are not actually included. And the same thing is true all the way down. We're going to go through some examples though, so I just want to skip through this. You could pause it at this point to look at the rest of these examples if you want to see some additional ones. But let's go ahead and write these intervals in, write the inequalities in interval notation. So let's say we have negative 2 is less than or equal to x, which is less than or equal to 4. So what I've done here is I've drawn a number line, okay? We have it shaded so that x is between negative 2 and 4. And if you want to write this in interval notation, again, you read from left to right. So if you're thinking about, we have negative infinity all the way over here. Okay, no shading, so we don't worry about it. We hit shading right here. So we write down our negative 2. We put a bracket because our negative 2 is included. And then it goes all the way till 4. And again, we put a bracket because 4 is also included. This one here, 2 is less than x, which is less than 7. This is very similar, except we have open dots instead of closed dots because those numbers are not included. Excuse me. Okay, so if you look, if we're going to read this from left to right, we hit a 2. Okay, we need to put a parenthesis because it's not included, and I apologize, this should be a positive 2, not a negative 2. And then it's shaded all the way up until a 7. Again, parenthesis, not a bracket. All right, now let's take a look at this one, x greater than or equal to 6, okay? So we're looking again from left to right, we're looking for shading, so nothing is shaded until we get to 6. So we do want to write our 6 down. There's going to be a bracket there because it's included. And then if we look here, we have this arrow. So what this arrow indicates is that it's just going on forever, okay? Now really what you have is you have positive infinity somewhere all the way on the right. Now that's not a real number, but it just indicates that it continues on forever. So in order to write this in interval notation, we write it as 6 with a bracket because it's included all the way up to infinity. Infinities are always going to have parentheses next to them since they're not actually real numbers. All right, and then this last one, x is less than negative 3. So if you look here, we have an arrow facing in the opposite direction. So that means that it's going to go all the way out to negative infinity. Now we're not going to include negative infinity because again, it's not a real number. So we go from negative infinity all the way up to negative 3. At negative 3, we have a parenthesis, not a bracket, because it's not included. So this should be from negative infinity up to negative 3, parentheses, everywhere. Okay. So there are a couple of properties that are going to be useful. Non-negative property just says that a squared is going to be greater than or equal to 0 for any real number a. And then addition property of inequalities basically just says that you can add something to both sides and you will keep the inequality going in the same direction. So you're allowed to add any real number to both sides of an inequality without changing the direction. Now, multiplication properties, what you need to remember is that if you multiply by a positive number, then your inequality stays the same direction. So that's this first line here. So if you multiply by a positive number on both sides, then your inequality stays the same. But if you multiply or divide by a negative number on both sides, then your inequality is going to flip. Okay, so you need to be careful with that. If you multiply or divide both sides by a negative number, then you need to flip the direction of your inequality. Now, reciprocal property, this looks a little confusing, but basically what you can do is you can take the reciprocal of any inequality on one of the sides and you won't change anything. So if a is greater than 0, then 1 over a is also greater than 0. If a is less than 0, then 1 over a is less than 0. If 1 over a is greater than 0, then a is greater than 0. And if 1 over a is less than 0, then a is less than 0 as well. Okay, so some procedures that leave the inequality symbol unchanged. Simplify both sides of the inequality by combining like terms and eliminating parentheses. So you can always combine like terms, get rid of parentheses, distribute, that sort of thing. You can add or subtract the same expression on both sides of the inequality. So for example, you could add 5 to both sides if you'd like. And you can multiply or divide both sides of an inequality by some positive number without changing anything. Now, procedures that reverse the sense or direction of the inequality symbol. If you want to rewrite 3 is less than x, you can rewrite that with x on the left-hand side as long as you flip the inequality. So this is going to be the same thing as x is greater than c. Or sorry, x is greater than 3. What you need to keep in mind is that if you have kind of a large opening, it needs to stay by the same number. So if you notice this large opening here is next to your x, it's still next to your x over here. So you need to make sure that that stays the same. Now, excuse me, if you multiply or divide both sides of an inequality by a negative number, then you need to actually flip your sign. Okay, so let's solve an inequality here. Let's say we have 5 minus 3x is greater than or equal to negative 1. So we solve this just like we would solve an equation. We're trying to get x by itself. Preferably, we would like to leave x on the left-hand side just because it's a little easier to read. So we're going to subtract 5 from both sides so that we get rid of this. So we're left with negative 3x is greater than or equal to negative 6. Divide both sides by negative 3. Now, when you divide by the negative, you need to flip the inequality. So what you're left with is x is less than or equal to 2. This can be written as either x such that x is less than or equal to 2, that's set builder notation, or negative infinity to 2 with a bracket, that's interval notation. And again, if you want to graph this, x less than or equal to 2 means that you start at 2 and you shade to the left. All right, let's say we have 4x plus 3 is less than 2x minus 1. We want to get all of our x's on one side, all of our other numbers on the other side. So we subtract 3 from both sides. So we're left with 4x is less than 2x minus 4. We subtract 2x from both sides. So we're left with 2x is less than negative 4. Divide both sides by 2. Since we're dividing by a positive number, we do not need to flip the sign. So we're left with x is less than negative 2. We can write this 2 different ways. Set builder notation, x such that x is less than negative 2, or interval notation, negative infinity to negative 2 with parentheses. And if you want to draw the number line for this, it's going to be a -2. You can either use an open dot or a parenthesis, and you're going to be shading to the left. Okay, combined inequalities are not really any more difficult than the other inequalities. You just have to keep in mind that you actually have 3 sides instead of 2. So what you want to do is you want to move everything away from x, but keep x in the middle. And whatever you do to the middle, you have to do to both the left-hand side and the right-hand side. So this one, they actually split it up into 2, which is fine, but my suggestion would be to go ahead and just subtract 2 from everything. So if you subtract 2, you get -3 is less than 3x, which is less than 3. So -3 less than 3x, that's the part that I just read. And then you also have, let me just skip through this real quick. You have 3x is less than 3, that's the other half. You solve both by just dividing by 3. So what you're left with is -1 is less than x, and x is less than 1. You can write that in one equality again. So if you write that in one equality, it's going to be x such that -1 is less than x, which is less than 1. Now, I don't really like how they split this one up. My suggestion to you would be when you have a combined inequality like this, to just go ahead and leave everything already put together so that you end up with this solution at the end. Now, since you have x between -1 and 1, that means that your interval is going to start at -1. It's not going to include it because it's not included here. There's no equal to part. And it's going to go up to 1, also not included. So you shade between those two numbers from -1 to 1. I always suggest as well, after you've solved inequalities, pick a number that's shaded and make sure that it does in fact work in your inequality. If it doesn't, then it means that you either mess something up with your shading or your answer or one of the steps along the way. All right, if you have something like this, 1 less than or equal to 5 minus 2x over 3, which is less than or equal to 3, we're just going to multiply everything by 3 in order to get rid of this fraction, which is probably the part that you guys don't like. 1 times 3 just gives you 3. The 3's are going to cancel in the middle, and 3 times 3 just gives you 9. Since we have a 5 here, we're going to subtract 5 from all sides. 3 minus 5 gives you -2. 9 minus 5 gives you 4. And then we have -2x, so what we want to do is we want to divide everything by -2. Recall that when you divide by -2, you need to flip your inequality direction. So what we're left with is 1, since we had -2 divided by -2, and 4 over -2 is -2. So we have 1 is greater than or equal to x, which is greater than or equal to -2. A nicer way to write this would be so that we have less thans. So we could reorder this so that we have -2 less than or equal to x, which is less than or equal to 1. Again, when you rewrite this, make sure that you keep the large parts, the openings, next to the same numbers. So for example, the opening here is next to your 1, so you want to leave that opening there. The small part is next to the -2, so you want to leave that there. And so your solution is going to be -2 to 1 with brackets, since those numbers are included. And if you want to draw it, you just shade in between those two numbers. You can also use the reciprocal property to solve an inequality. So if you have this equation here, or sorry, this inequality here, where you have 1 over 3x plus 6 is greater than 0, what you can do is you can just ignore the fraction part, flip it around, and just say that 3x plus 6 is greater than 0. You guys all know how to solve that. You get x is greater than -2, which you can write in interval notation from -2 to infinity. And if you're shading, you start at -2 with a parenthesis, and then you shade to the right. Okay, section 1.6 talks about equations and inequalities that involve absolute values. So I don't have the rule written here, I just wanted to go through a couple of the equations. What you want to make sure when you're solving absolute value equations is that the absolute value part is by itself first. And then what you do is you just split it into 2 equations. One, you just write the exact same way, but without the absolute values. So you just write it as x minus 3 equals 10. You just drop the absolute value. And you also split it so that you have, again, this same thing without the absolute value, the x minus 3, but then you say that it's equal to -10. Absolute value really just indicates a distance from 0 on a number line. So it can either be positive or negative. inside, but the absolute value is always going to be positive since it's a distance. So we just break this into x minus 3 equals 10, or x minus 3 equals negative 10. And then we just have two equations, so we solve them. So we get x equals 13, or x equals negative 7. Now this one here, the only thing that you need to keep in mind first is that the absolute value has to be by itself before you actually solve it. So you want to add 3 to both sides first. So you have absolute value of 2x plus 1 equals 10. You split this into 2, so you have 2x plus 1 equals 10, or 2x plus 1 equals negative 10. And you solve those, so you get x equals 9 halves, or x equals negative 11 halves. So those are your solutions right there. These are really easy to check, so please make sure that you go back and check both of the solutions to make sure that you're correct, especially when you're doing a quiz where you only get one chance. Okay. Now here's a theorem for when you have less than. So if a is a positive number and u is an algebraic expression, then what we can say is that the absolute value of u is less than a is just equivalent to this here. So what you do is you rewrite the original u less than a without the absolute value, but then what you need to do is you need to add a negative a over here and put an absolute value, or sorry, an inequality symbol that's facing the same direction. Now you do not need to memorize this second line here. This is the same as the first line, but with an equals piece as well. So let's try this. Let's say we have absolute value of 3x minus 1 is less than or equal to 5. So all we do is we rewrite it without the absolute values. So the first thing you want to do is just copy it straight down without the absolute value. So you have 3x minus 1 is less than or equal to 5. And then what you want to do is you want to put your negative 5 over here. Okay, so you always make this number negative and keep the inequality facing the same direction. And then you have a combined inequality that you solve. You add 1, and then you divide by 3. So what you're left with is negative 4/3, which is less than or equal to x, which is less than or equal to 2. In interval notation, this would be negative 4/3, comma 2, both with brackets since those numbers are included. And if you wanted to shade it, it would be shaded like this. Okay. I think less than's a little easier. Greater than is slightly trickier. What you need to do is you need to break it into two separate things. So instead of using a combined inequality for this, you break it into two separate problems. So if you have absolute value of u is greater than a, the first thing you're going to do is you're just going to write that absolute value, without the absolute value. So you just have u is greater than a. And then for the other piece, what you need to do is you need to flip the sign. So you need to make it a negative a, and you need to actually flip the inequality direction as well. So you have u is less than negative a. So the easiest way to show you guys is to just do one. So let's say we have absolute value of 3x minus 2 is greater than 7. So we rewrite this two different ways. The first way is we just drop the absolute values. So we're just left with 3x minus 2 is greater than 7, which should be pretty easy to solve. And then on the left-hand side, what we're going to do is we're going to flip the inequality direction, so it's less than, and we make our 7 into negative 7. And then we just solve them independently. We're going to add 2 to both sides, divide by 3. So we're left with x is less than negative 5/3, or x is greater than 3. Now, if you're doing this in interval notation, you put these together with this union symbol, okay? So if you look at the shading, we have x is less than negative 5/3. That means we're going to start at negative 5/3, which is negative 1 2/3, and we're going to shade to the left. And we're also going to start at 3, and we're going to shade to the right. So in order to write this in interval notation, what you'll notice is you have this arrow here going indefinitely in this direction. So you're going to start at negative infinity. You're going to go up to negative 5/2. You're not going to include it, so you're going to put a parenthesis. And then this union symbol is going to put the two pieces together. And then you start at 3. Again, you have a parenthesis because it's not included, and it goes up to infinity. All right, the last section is section 1.7. We're going to do some problem solving here. There are a bunch of different kinds of problems in this section, but we're going to cover an interest problem and a constant rate job application problem and a mixture problem. So there are some kind of useful steps in order to solve these. My suggestion to you would be to definitely read the textbook and take notes on this section, because these just take a little getting used to. So the first step is to read the problem carefully, perhaps 2 or 3 times. Pay particular attention to the question being asked in order to identify what you're looking for. And if you can, go ahead and determine realistic possibilities for the answer. So you want to think about what kinds of answers are going to make sense. Step 2 is to assign a letter or a variable, which is a letter, variable, same thing, to represent what you are looking for, and if necessary, express any remaining unknown quantities in terms of this variable. Make a list of all the known facts, that's step 3, and translate them into mathematical expressions. These may take the form of an equation or an inequality. And then if possible, you want to draw an appropriate labeled diagram to assist you. Sometimes you could use a table or a chart. Step 4 is to solve the equation for the variable and then answer the question. And then step 5 is to go ahead and check it with the facts of the problem. So one thing you need to know is this simple interest formula here. So if you have a principal of P dollars and it's borrowed for a period of T years at an annual interest rate of R, which is always going to be expressed as a decimal, then the interest is just found by taking the principal times the rate times the time. So let's suppose that you borrow $1,000 for 6 months at the simple interest rate of 6% annually. What is the interest you will be charged on this loan? And then if you pay the loan back at the end of 6 months, what is the amount that you must pay? So we're going to use our equation. We have our principal, which was 1,000, multiplied by our rate. We needed to change that to a decimal. So if you rewrite 6% as a decimal, it's going to be 0.06. And then the thing you need to keep in mind is that time is going to be in years. So in this case, 6 months is just 1/2 of a year. So that's why this is 1/2 year. And if you multiply those, you get $30. So after 6 months, what you would owe is the amount that you borrowed plus the interest. So you're not earning interest, this is a loan. So you would owe the $1,000 plus the $30 in interest. So you would owe a total of $1,030. Okay, blending coffees. So this is kind of a mixture problem. So the manager of a Starbucks store decides to experiment with a new blend of coffee. She will mix some B-grade Colombian coffee that sells for $5 per pound with some A-grade coffee that sells for $10 per pound. She wants to make 100 pounds of the new blend. The selling price of the new blend is going to be $7 per pound. There's going to be no difference in the revenue from selling the new blend versus selling the other types. So she wants to know how many pounds of grade B and how many pounds of grade A coffee does she need to make the 100 pounds. So what we're going to do is we're going to let X represent the number of pounds of the B grade coffee. Now, we know that together we need to have 100 pounds. So we know that 100 minus X is going to be the number of pounds in the A grade coffee. So if you look at this drawing here, we have our B grade coffee, our A grade coffee, $5 per pound, $10 per pound. The blend is going to be $7 per pound. The blend is 100 pounds. So if we call this X, this has to be 100 minus X. So for example, if we have 25 pounds of B grade, that means we need to have 75 of A grade in order to have 100. So what we want to do is we want to take the price per pound of our B grade, which is $5, and multiply by the number of pounds, which is X. We take the price per pound of our A grade, which is $10, multiply by the number of pounds, which is 100 minus X, and then we add those two things together. Those should equal the blend, which is going to be our $7 times our 100. So this, it's not all worked out here, but you're going to have 5x plus 1,000 minus 10x equals 700, just by distributing everything. You're going to get all of your x's on one side, all of your numbers on the other, and just solve. It should be a really easy linear equation. And what you should get is you should get x equals 60. So that means that we should use 60 pounds of the Colombian coffee and 40 pounds of the grade A coffee. Okay, working together to do a job. So at 10 a.m., I think this is our last example. So at 10 a.m., Danny is asked by his father to weed the garden. From past experience, Danny knows that this will take him 4 hours working alone. His older brother Mike, when it is his turn to do this job, requires 6 hours. Since Mike wants to go golfing with Danny and has a reservation for 1 p.m., he agrees to help him. Assuming no gain or loss of efficiency, when will they finish if they work together? Can they make the golf date? So what we want to do is we want to put the part that's done by Danny in 1 hour and the part that's done by Mike in 1 hour together, since they're working together, and that's going to be the part that's done together in 1 hour. So it takes Danny 4 hours to do the job, so that means that in 1 hour, he'll have 1/4 of the job done. It takes Mike 6 hours to do the job, so that means in 1 hour, he'll have 1/6 done. So together, that's going to be T. They're going to have 1/T done. So we put our 1/4 plus our 1/6, that's going to be our 1/T. You can either do this in a calculator or you can use common denominators. You should get 5/12 equals 1/T. And then you cross multiply, you get 5T equals 12. So T is 12/5. So working together, that means that they can get the job done in 12/5 hours, which is not a very nice number. You would want to change that. That would be 2 hours and about 24 minutes. So that means that if they start at 10 a.m., they're going to be done at 12:24 p.m., so they should be able to make their golf date, which is at 1 p.m.